Hi, welcome to the screencast for the Topic 1 quiz solutions. I'm not going to type out the problems just because it's not a convenient thing to do, so I'm going to assume you have a sheet of paper or have your quiz nearby where you can read the problems as we go. So starting with question number 1, you're asked what is the mass in grams of one molecule of ethanoic acid? And you're given the formula of CH3COOH. So if you want to know just one molecule, you'll have to start by finding out how much a mole weighs. And if you add up the 12.01 times 2, 4 times 101, and the 2 oxygen, most of you realize it has a molar mass of 60.06. And remember, this is grams per mole. So now to find out the mass of just one molecule, I can take that 60.06 grams per mole. I can multiply by 1 mole, which contains 6.02 times 10 to the 23rd molecules. So by setting up my conversion factor this way, my moles will cancel out and my final answer will be grams per molecule, which is what we were asked to find. And dividing by Avogadro's number, I come up with 1 times 10 to the minus 22nd. Moving on to question number 2. Question number 2 asked, which is not a true statement? First statement says 1 mole of methane contains 4 moles of hydrogen, and methane is CH4, so that is a true statement. B says 1 mole of 12C has a mass of 12 grams. And 12C, if you look it up, that is the mass number up there because the atomic number would be 6. So that is a true statement. C says 1 mole of hydrogen gas contains 6.02 times 10 to the 23rd atoms. And if I think about hydrogen gas as H2, so 1 mole would actually contain twice that many atoms. It would be 2 times 6.02 times 10 to the 23rd atoms, because a mole of H2 would be molecules. And then D is also a true statement. 1 mole of methane contains 75% carbon by mass. And if we go back to methane being CH4, that means its mass is 12.01 plus 4.04. So then the percent of carbon is 12.01 out of 16.04, which is 75%. So the only false statement or non-true statement would be C. Question number 3 says a pure compound contains 24 grams of carbon, 4 grams of hydrogen, and 32 grams of oxygen. And you are asked to find its empirical formula. So getting these into molar amounts, divide by each's molar mass. I may end up with approximately 2, 4, and 2. And some of you wrote this then as C2H4O2. But remember, empirical formula is the simplest ratio, so I divide each of them by the smallest molar amount I got, and this reduces to 1, 2, 1, or CH2O, which corresponds to letter B. Number 4 asks, which of the following statements about SO2 is or are correct? So statement number 1 says 1 mole of SO2 contains 1.8 times 10 to the 24th atoms. Well, SO2 is a total of 3 atoms, 1 sulfur, 2 oxygen. So if I take 3 times 6.02 times 10 to the 23rd, that is a true statement, that it contains 1.8 times 10 to the 24th atoms. And the number 2, most of you found this to be a true statement. 1 mole of SO2 has a mass of 64 grams. If I take the mass of sulfur, it's 3207 or 3208, I don't remember which, and the 2 oxygen, and it is approximately 64 grams per mole. So this is also a true statement. Problem on the first part is a lot of you took this 64 grams times Avogadro's number, which I'm not sure why, because units don't cancel out when you do that. You should have known that there's 3 atoms per molecule of SO2, and there's 6.02 times 10 to the 23rd SO2 molecules in a mole. Moving on to number 5, what is the empirical compound for the formula? And you're given C6H5OH2. An empirical formula means simplest ratio, so it means you get rid of the parentheses, you go ahead and distribute through, you combine. So this would really become C6H7O2, and then that is its empirical formula. So that matched up with D for number 5. Number 6 says a carbohydrate has the empirical formula of CH2O. This is actually the one we found just back in number 3. It has a relative molar mass between 160 and 200. So it falls somewhere in there, but we're not sure where. And it asks, what's its molecular formula? Well, if I find out the mass of the empirical formula here, 12.01 plus 2 times 1.01 plus 16. So I see that the mass of the empirical formula is 30.03. If I divide the 2 extremes by this, 30.03, the low and high, then I see that my range is really somewhere between 5.3 and 6.6. Well, it has to be a whole number ratio of this. Okay, it has to be some multiple. So the only whole number that falls between 5.3 and 6.6 is 6. So I could take 6 times the empirical formula of CH2O, come up with C6H12O6, which matches with letter C. Number 7 says phosphorus burns in oxygen to produce phosphorus pentoxide. I'm guessing a few of you are a little upset that you got this one wrong. When you balance this, you have P4 plus O2 yields P4O10. So you need a 5 here for the O2. The P is balanced. When you add up your coefficients, then you have 1 plus 5 plus 1 for a total of 7, which was letter D, although a bunch of you went with letter B, counting only the 5 and forgetting that no coefficient really is equal to a coefficient of 1. And number 8 says magnesium reacts with hydrochloric acid according to the following equation. And they want to know the mass of hydrogen that will be obtained. And what you really need to do is come up with your limiting reactant here. So actually I'm going to go to a clean page for this one. So if we start out with the formula given and write in the amounts we know, we have 4.86 grams of magnesium. The hydrochloric acid, we have 100 milliliters, which is 0.100 decimeters cubed, with a strength of 2.00 moles per decimeter cubed. That's going to yield MgCl2 and H2, and we're being asked to come up with the amount of H2. And by amount, I actually mean the grams, I believe. Yes, we want this in grams. So to complete this then, I need to find out my limiting reactant first. So magnesium with 4.86 grams is really, if I take 1 mole and divide by the 24.31 grams per mole in magnesium, I see that I really have 0.1999 moles of magnesium, which would yield 1 mole of H2 for every 1 mole of magnesium, or 0.199 moles of H2. And now I need to compare that with what I would get from HCl. HCl, I have 2 moles per decimeter cubed, but only a volume of 0.100 decimeters cubed. So I have 0.200 moles of HCl. Right now it looks like they're pretty equal. I mean, 1/10,000th is pretty slim to call, except when I look at the molar ratio, I only get 1 mole of H2 for every 2 moles of HCl. So even though I start with about the same molar amount of each reactant, this will only yield 0.100 moles of H2, which means HCl is my limiting reactant. Now that I have my limiting reactant, I know I can only make 0.100 moles of H2. I could go ahead and multiply by H2's molar mass. And that's how I came up with my final answer of 0.2 grams, or letter A. Okay, moving on to number 9. Number 9 just tells you straight out that they want to know the limiting reactant. And they give you an equation of 2C4H10, that's butane. It's going to combust with 13 oxygen and yield 8 CO2 and 10 H2O. And you're told you have, I believe it's 15 grams of each, no, 11.6 grams of each one. Which one will limit your reaction? And so you can determine how much carbon dioxide or how much water either one makes. I set mine up looking at the carbon dioxide just because it was the first product listed. So my C4H10, my butane, if I'm starting with 11.6 grams, I have to find the molar mass of butane, which is 4 carbon at 12.01 and 10 hydrogen at 1.01. So I came up with a mass of 58.14 grams, which gave me 0.1995 moles of butane. But again, I need to know how many moles of product it would yield, and it's going to give me 8 moles of CO2 for every 2 moles of butane. So that's going to be a factor of 4, or this is going to increase to 0.798 moles of CO2. In contrast, my 11.6 moles of O2 have a molar mass of 32 grams per mole. So that means I have 0.3625 moles of oxygen. But again, even though I start with more oxygen, I have to look at what I end up with. And from the oxygen, I only get 8 moles of CO2 per 13 moles of O2. So I'm going to see a decrease here to 0.223 moles of CO2. So even though there's more moles of O2, it produces less CO2, and O2 is my limiting reactant. Okay, number 10, I will have to continue on to another recording, so 10 through 14 will show up on part 2.